Welcome to my YouTube channel once again. In this video, we're going to look at the concept of the concept of differentiation. Differentiation is a topic that is widely taught in mathematics, but it has an application in economics. As a matter of fact, as an economics student, it's very, very important for one to be conversant with the concept of differentiation, because as you progress in the discipline, you get to meet the concept of differentiation in virtually all the area of specialization, or you can find the concept of differentiation in microeconomics, in macroeconomics, mathematical economics, as well as in econometrics. So it is actually a mathematical concept, but being introduced into economics, and then most importantly apply into the area of economics. So please, if you have not subscribed to my YouTube channel, kindly subscribe in order to encourage me to keep creating concept that will content that will help in teaching you economic concept and making you understand and pass your exams in economics. So thank you very much. So differentiation is the process of finding derivatives of a variable in relation to another variable or several variables. Differentiation enables one to determine the change in a dependent variable as a result of the change in an independent variable or in several independent variables. Assume two variables, x and y, are related, considering that the rate of change in y is as a result of rate of change in x. Then the functional relationship can be presented as y is equal to f of x. So in this case, y here is the dependent variable and the x is the independent variable. The f here, signifies that y is a function of x, meaning that y is dependent on x. The change in x will lead to a change in y. So based on the above, or based on the function stated here, we say that y is a function of x. We call x the independent variable and y the dependent variable. So in order to understand the concept very well, we're going to look at some examples, which, by the way, as we progress into as we progress more into the topic, we'll get to understand the rules of differentiation more and more. So I have about 8 examples here that I want us to look at one after the other. So number one, we have fx is equal to fx is equals to 100. So the solution to this, let's say the solution we have f prime x. This f prime x is basically the same with the y, the x that is mostly used in other texts or in mathematics. But since the question is given to us in form of fx, So we use f prime x, instead of the y, the x. Yeah, so in this case, the solution is what? 0. Why is it 0? Because 100 is a constant. So when you differentiate a constant, what you get as the answer is 0. Differentiating a constant gives you 0 as the solution. We're going to look at that subsequently. So second question, that's number 2. We have f(x) equal to x raised to power 7. So our f prime x will be equal to what? Our f prime x, yeah, in this case will be equals to 7 and then x raised to power of 6. Yeah, we multiply x by the power. That's, we multiply x by 7 and then we subtract 1 from the power. That's another rule of differentiation, which we are going to look at subsequently. Number 3, we have fx equal to exponent x. So the f prime x in this case is equal to what? Exponent raised to power x. It remains the same. It doesn't change when you are differentiating an exponent raised to a power of a variable. Yeah. So the next question that comes is closely related to the number 3. That's number 4. In this case, we have fx is equal to exponent raised to power 7x. So in this case, we have x prime x is equal to 7 exponent 7x. 7x. Yeah. If you look at number 3 and 4, they are similar, but the fact that the exponent has a constant together with the variable. So the rule in this case is that you multiply the exponent by the constant, and then the power remains the same. Yeah. So number 5. Number 5, we have fx equal to 8 to the power of x. So the f prime in this case will give us equal to 8x and then natural log of 8. Yeah. So this is the rule for this. Number 6, we have fx equal to natural log of x. Yeah, so in this case, our f prime x, our f prime x, yeah, will be the same thing as 1 all over x. This is another rule of differentiation. If you're differentiating, the natural log of x is 1 all over x. Number 7, we have fx equal to, we have log 3 power x. Our f prime x will be equal to 1 all over x and then natural log of 3. Yeah. And then the last question, but not the least, number 8, we have fx equal to x minus power 9. So our f prime x will be equal to minus 9 and then x minus 10. And in this case, we can say it's the same thing as minus 9 all over x raised to power 10, if we like. Yeah, so these are some of the examples of differentiation that that we have. So and then we have several rules of differentiation that may be helpful to us, you know, in future times solving some of the problems. So we have the constant rule, we have the linear rule, we have the power rule, we have the sum and difference function rule, we have the product function rule, we have the quotient rule, we have the generalized power function rule, and we have the chain rule. These are there. So these are the common rules in differentiation that we'll look at. So for now, we'll stop here in the first video, and then subsequent series will follow, so that we get to understand the concept of differentiation more. After that, we'll look at the application of differentiation to economics. So thank you very much once again for watching the video till the end. Please, like I said earlier, subscribe, watch the videos, comment, share, like. Any problem, any challenge you have, you drop a message there. I will respond to you, and then probably maybe engage people in seeing how we can solve problems that may be difficult to the student. So thank you very much till I see you in the next video.